Good evening and welcome to the Q&A session 13 from the playlist of oscillations. The topic is the calculation of time period of a simple pendulum when the bob is charged. So this session is in continuation of the session number 12, in which we have learned about the formulas of time period of a simple pendulum in different situations. So in that session we have also learned that the time period of a simple pendulum when the bob is charged is given by the formula, that is T is equal to 2 pi under root L upon G plus minus QE upon M. So this was the formula which we have learned in the previous session. That is, this is the formula for the time period of a simple pendulum when the bob of that pendulum carries a certain charge. So in this formula, I will write this formula here. T is equal to 2 pi under root L upon G plus minus QE upon M. So this is the formula for the time period of a simple pendulum when the bob of that pendulum is carrying a certain charge. So here in this session we will be simply deriving this formula with the help of the parameters which has been given in this question. So in this question there is one there is one pendulum, and this is the bob of it, which carries a charge Q, and this bob is connected to an inextensible string which is connected to this rigid support. So this is the figure which is showing a simple pendulum whose bob carries a charge Q coulomb, and the mass of the bob is small m kg, and the pendulum is placed above a negatively charged plate. So this is a negatively charged plate, and the pendulum is placed above this plate as shown in this figure. Now the electrical field intensity in this region is E Newton per coulomb. So we have to find the time period of the pendulum when the bob is displaced from its mean position. So this is its mean position. So when I am displacing this bob from its mean position, so in that case we have to find the time period of oscillation. So in this case, since this is a positively charged bob and this is a negatively charged plate, so the direction of the electrical field lines will be as given by this arrow. The electrical field lines are directed from the positive charge towards the negative charge, and because of this, an electrostatic force will be exerted on this bob, which is equal to Q into E, and the direction of this force will be vertically downward. So now force is equal to Q into E, and this is also equal to mass into acceleration, where m is the mass of this bob. So the acceleration which is generated because of this electrostatic force, this will be equal to QE upon m. Now at the same time, this bob is also experiencing the acceleration due to gravity, which is also acting vertically downward. So the net acceleration will be equal to G plus QE upon M. Now we know that the time period of the pendulum is given by the formula, that is T is equal to 2 pi under root L upon G, where G is the net acceleration. So in this case, the value of the net acceleration is equal to G plus QE by M. So the time period of this pendulum when it is displaced from its mean position will be equal to 2 pi under root L, where L is the effective length of this inextensible string, divided by the net acceleration, which is equal to G plus QE upon m. So this will be the time period of oscillation of this pendulum when the bob is displaced from its mean position. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question from the same topic of time period of a simple pendulum. So till then, have a nice day. Bye.